Okay, now we are going to start connecting all the different parts of the pump, and yeah, as you can see here, I have the layout open with all the modgens already with their rings and wells. This layout looks a little bit different than the previous layout, and the reason is that I have to redo the complete layout due to some strange problem that I have with OneNet. But it is basically the same. I have rotated this resistor, and then I have just made this modgen without one of the trunks, without two of the vertical trunks, but otherwise it is exactly the same that we have been done before, just slightly different routing for the modgens. At this point, we have everything ready for connection. We're going to do it now. It is to open the annotation browser that it is going to help us to connect everything. So put the annotation browser on the right, and then we open, and it will tell us all the incomplete nets we have here. And what is very nice is that every single net that we click in the browser will be activated. You see that it is telling me where it is missing a connection, so it will immediately allow me to correct and add the connection that it is needed. At some point I will basically finish doing this. So something else that it is very common in analog design, it is that we used to put some piece of metal, a trunk for VDD and one for ground. So we can do it here. And we can adjust the dimensions on this one. So let's see, we can put it, for instance, 10 micrometer, and this one also 10 micrometer. And okay, fine with that. And I will make them touch already these rings, so we can select this rectangle and use the alignment. So very important, if you have not used before, the alignment tool is something that you should really learn. Yeah, you click something that you want to align, press A, and then select the reference that you want to align of the object that you want to align, and then select the reference that you want to align with, click, and then it will move perfectly aligned. So now we have connected these two here. Let's see, here on the top, I think I will want to keep it as it is for the moment. I don't want to make it very close to the capacitor because it will add some fringing capacitance, so let's leave it as it is for the moment. And then I will start connecting the things, and we can start in any node that we want, but I will suggest you to connect first the signal path, because those are the connections that are more sensitive to parasitics. So let's start with the differential pair. In the differential pair we have the following connections. We have the differential pair, we have the node B, that is the sources, and then nodes C and D, that are the drains. So let's see in the node B. We have the node B here. It is. We have a node B in metal 3 and metal 2, metal 3, and it is connected to the cascade here. And we see that it is probably much more useful to have these transistors flipped vertically, so they get a little bit closer. Reduce a little bit the parasitic. So we have node B and node B here. Okay, now I'm going to bring it this. We can connect it like this B. So you notice that the tool is telling me the minimum spacings that I should respect. And then connected, and we can see that node B has disappeared. Now I could have done it a little bit different, trying to go from metal 3 coming directly to the center here. We will see later in parasitic extraction if there are some issues with capacitance. So for the moment I think it is correct. We have node D and node C, but now I remember that I have things that are disconnected inside the modgen. For instance, this dummy. The dummy should be connected to ground, the gate drain source, and they are not connected right now. So let's take a look. And it's not here, not this one, not this one. Let's see if we can pick up some of these ones around. Okay, so they are here. So you can see that these are disconnected, and I need to connect all the dummies. So what we can do it is we go to metal 1, and then we select P for path, and then we can take it from any of the gates, and then we go down. So we don't even need to click immediately. It finds its way to the source or drain. So click it and it is connected. So we have 29 and we have 28. We do the same to the other side. Now we want less, and now we need to connect these ones to ground also. So we just need to connect one. I will take the external ones and send and connect it down to the ring that is also grounded. Okay, I will do the same on the top. So it is a little bit of manual work, but it is not really much. And I take the external and connect it to ground. I do the same with the dummy that is in the other side. Connect it here, connect it there, and then I take the external and connect it to the ring, the piece of straight ring. And the last one, very quickly, connect this one, connect this one. Okay, so we are down to 17 grounds that remain to be layout. So I feel happy with that. I can continue. Now I'm going to connect the. I have just connected all the dummies. Now I'm going to connect node C and node D, the drains of the differential pair. So we have node D and C. We have both sides, and in the current mirror here on the top we have D on the right and C on the left. So let's take it from here, D. So we are going to use metal 3. So we can connect it here like this. Now it is like that connection. Let's see. P. Okay, now it is correct. We connected D, and then we're going to take C. It was not nice. Let's see. I want to be it exactly in the center. Oh, it's better to come from the other side. Go like this. And then it is connected directly. Yep. So we have connected C and D there. And then we are basically done with the differential pair. Now let's go to the top. In this current mirror we have the dummies. The dummies are already connected to VDD here, but the gates are not connected. So we need to do this manual connection, and we do the same as we did before. Let's see, we have 9 connections that need to be done here. So take this one. We're going down to 8. Here. And then for symmetry, I just connecting the other side as well. Okay, now we are down to 5 connections of to be the remaining. Good. Then we need to connect VDD. And we have first the wells. I can connect the wells are not really carrying current, but they need a decent connection. I'm going to use a rectangle here for these ones. Let's see it like this. Actually, it is not a good idea to do it like this for now. Let's see. Let's try to bring it from there. We have VDD on the top that it is large. For VDD in the top, I have several alternatives. One it is that I can bring the connection from metal tree like this and like this. Then I have connected VDD there, and I can do it from the other side as well. VDD and connected here also. Yeah. So I have connected VDD there. I could have also taken from the center metal tree and then go to the other side, but probably that should be okay. I have also a connection from VDD here. I can connect it directly here. If I am not happy with the width of this VDD, I can probably make it a little bit larger using a rectangle. I still have a lot of space there. I have a better connection to VDD there. Can you stretch it if I want a little bit? Yeah. Now it is a good time to check if there is some DRC violation, so we can correct it before we continue forward. let's see. So there is some violation, minimum and well spacing different nets. And this is located where? Okay. This we fixed this very quickly. These nets are going to be connected to BDD, so it really doesn't matter. We are going to connect them now. Let's connect them and wells. Let's see, metal 1 here. Close this one now, so we can fix those very quickly. So the tool is telling me that these end wells are too close, and it shouldn't be too close if they are connected to different nets, but they are actually the same net as BDDA. So to make it explicitly, we are going to short circuit these ones. This one be shorted with this one, and that node should disappear. That error should disappear here. And we have also the one that is connected to the resistor. It should be connected, so we just connected this one. Now we have the 3 end wells short circuit here. Okay. Now here I'm going to put the contact letter O. I'm going to put contact via 1, so from metal 1 to metal 2. Let's see, something decent with enough contacts to make the contact to VDD. So probably that should be okay, as long as it doesn't give DRC errors. Let's see. So now I have contact VDD. I have contact VDD via metal 1 and metal 2. I have contact this to the rings, to the end well rings here. Okay, I have contact these ones here. I can probably improve here the lower the resistance in this side for VDD. And that's it. For the moment I think that is okay. We have still one VDD that it is open, and I think it is this end well here. So I will connect it here, that one. This is probably not the best idea. We're going to do like this. We're going to bring these VDDs from here. I want to keep separated the connection from the end wells from the resistor and the capacitor. They are going to connect directly to VDD on the top. The reason for that is that I don't want that activity in the transistors will propagate to the end wells that are under the resistor and the capacitor. So I will prefer the connection directly to VDD. So in other words, this will behave like a star connection. Again, we came the connection here. Probably this should be more than enough. Here we trim this one a little bit with S. do the connection. This one in metal 2. Metal 2 connection. Oops. You can use a rectangle instead. So we do the connection to VDD. Now, so now the N-well connections to VDD are separated from the transistor and for the resistor, and I will do exactly the same for the for this N-well. This connection for the N-well, I will connect it separately. So let's copy paste this one. We just copy F3 orthogonal, and then I will only move orthogonal this one, and that should be okay. So now they are connected, the N-well separately. We can extend a little bit this to reduce the resistance. Here, like this. Okay, and so, oh, maybe not needed. We can do something different. This one, I move it here. This one we delete a little bit. Let's try to put it in the center. Doesn't have to be perfect. That will make it. Spacing is going to draw on DRC. We're going to change to 2 rows. Apply, and let's make it a little bit longer, and that will make it. No, that will be okay. Now we connect it through metal 2. How does it look? That will look okay. Yeah. And let's check the DRCs now. PBS DRCs. Submit. Yes. So it's DRC clean. Okay. So we have basically connected all the all the VDDs. Now let's go forward. We need to connect C. C is going to both the resistor and the gate of the output transistor. So C is here, and then we have C. C is also here. And we have also C here, and it has to connect. We have a C here, so we can bring it from here. And in this particular case, it doesn't have to be very wide because it is just carrying a voltage and not current. So we really don't need to use 1.5. Let's change it to 0.5. That it is going to produce slightly less capacitance and still be larger than minimum dimensions. So we come here and can come to the -C here. Let's stop there, and then let's put 2 rows and 4. That should be enough. Then we have only 1 C remaining. We do the same thing from here, and that C will be here. Can do like this and get it exactly in the middle. So we come here. Oops. Let's try it again. Here and here. And then we do exactly the same here. Let's see if it try to put a little bit in the center. Let's see if this passes the RCs, and we move forward. So as you see, I mean, this is just connecting the modgens. It is very quick. Oh, there is no errors that has been detected. There are DRC errors are zeros here, so we can move forward. Now there is now we can move to the current mirror. So we go to the current mirror, and in the current mirror we have a lot of grounds that have not been connected. This is the main net here, and then we have the dummies. For the dummies we can I mean, it is not strictly necessary to connect as I'm going to connect, but I want to do it as symmetric as possible. So let's do it like this, like this. Okay, so now we are down to 3 grounds that need to be connected. Most probably are the wells, we need to connect only the rings here. So we're going to quickly connect this ring here. Can use a large metal, but we went back down to 2. And for this one we do the same. We connect this one and this one here down to 2. And there is one ground that it is missing. Which one? Ah, the ground from the current mirror needs to go down. Okay. That one, let's see, the current mirrors, we have ground at both sides in metal 3. So in metal 3 they are collecting the grounds here. So we can take both. Here the ground connections have to be very good. So, let's see this one. This is 1.5. So we go down to metal 1 here, and then we go all the way here. Oh, to be exactly in the middle. Okay. And then we're going to bring this ground that we have collected in metal 3 directly to metal 1, and we can use a lot of contacts for this one. Let's see 40. That should be more than okay. but this was not it's not a stack. So we're going to stack from metal 1 to metal 3. So use the stack here. There are many other that you can try, many other options that it's worth to try. So 1, 2, 3, and then let's put this 60, and yeah, somewhere here close to the middle. Let's try to use the alignment so you also learn how to do this kind of alignments. So we're going to align this this contact. We press letter A, and then this is the center. You can see that it is a cross there. We're going to align this center, and this is the middle transistor, the one that is exactly say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's here is the middle. So we're going to align with this here. So we're going to align with this line here, and then it has been aligned. Now I'm going to align this one, the top with this one, so now it is placed there, almost perfect. Okay, so let's take a look. It is metal 3. There is contact from metal 2 to metal 3. There is metal 2. There is via metal 2, metal 1, and then there is metal 1. So it is connected. We can see everything, and then it has disappeared. That one. Yes. Now what it is remaining is to connect the node A. Node A, it is here. It is bringing current to the current mirror. So we are bringing from here. We can use this metal tree that we have collected this current. We can bring it from here. Oh, it's not here. This node A. Where is node A? Node A is here. Node A. Okay, this node A, and we bring it like this, like this, and here we have two options. One, it is we finish the track and insert and manually and contact. But we have another option here. We can right click and then via down to metal 2, and then it will insert the bias automatically, but I don't like it because it's just going to insert 3 bias. We can configure this and see. Select bias. No, I prefer not to do that. Like that. So let's do it like this. I prefer to insert the bias manually, so I can put the number of bias that I want. So I just put it here on the top, and then I can put metal 2 to metal 3, a single bias. That will be bias 2, metal 2 to metal 3. That will be 3 rows, and then let's say 8. That should be more than enough. This is just carrying the very little current here. Okay, so node A is gone. So we are here, and this is node A that is carrying this current, so it is very little. And then we need bias. It's telling me this transistor is not connected, and it has to be connected to here. So we can run a connection first from these two together. I disappeared one, and then I need to short these two. Okay, so this one is not carrying current, it is connected only to the gates, so I can keep it. And what is the width of this one? It's 0.34. So let's make it 0.5. I don't like to run minimum sizes here, and it is not nice. See, this 0.5. I want it to come exactly in the middle. Oh, it doesn't allow me. Okay. It is the auto root tool. It creates me some problems here. Okay. So we're just going to do it like this, and then I'm just going to use a contact here, metal 1 to metal 2. It's going to be via 1, and then that disappears. And there are only 3 nets that need to be laid out before we finish. Net 6, that should be the, what is net 6? Net 6 is this connection between the resistor and the capacitor. So it is telling me this one here. So let's see here. The output, it is connected in metal 4, and the plus is connected in metal top. So I need to bring it. I need to bring this connection from the top. So what I will do here, it is then can put the whole stack. I will bring a stack from metal 2 to metal 4, and I want here it is not really very important. I mean, it's a resistor of 60 kilo ohm, so I really don't care much about the resistance here. So we put this 2x4, and then I get closer with the metal 4 to the let's put 1 micron in the middle. Let's see. Let's try with this one. Okay. So it's net 6, and then I have to go to metal top. So I will put one contact here that it is going to metal metal TP. Okay, and can put 4. That should be okay. We put it here. So for this net 6, that will be in this metal. And now I can connect it. It is justifying wrongly. Now it is in the center. Okay. And let's make it 0.5 also. Okay. Then, yeah, we have that one. Then I am missing this one. What it is? That will be net 5. What is net 5? Okay, net 5, it is located between the current mirror and the cascode transistor. Okay, so it is here, and for that one, we are collecting all the currents in metal 3. What we can do it is to bring it from the center. This is 1.5. And then I'm going to bring it under the metal. I want to bring it here. Let's see if it works via up to metal, and yeah, it is connected. Yeah, very nice. So it is connecting with the 9 contacts. So I am bringing this directly. So this metal recollects all the currents to this net, and I am bringing them directly to the cascode here. And then the things that are remaining, it is just to connect the output that it is in metal 4 from metal 3 that it is here. So I'm going to do this pretty quickly. I come here. I need to bring it metal 3 to metal 4. That will be this one, this one here, and let's take a look. Metal 4, and then I just connect the capacitor. Okay, and I will use 0.5. I shouldn't use minimum dimensions here. And there is one thing that is missing. What can it be? Oh, of course, the output transistor. The output transistor needs to be connected to the output naturally. And then we have that one. We have the output here. The output transistor is a bit far away. We can bring it like this, and I will route over the resistor. It really doesn't matter because it is just a compensation resistor, and it is not much to anything, so I can route it. If I don't want to route it, I can still do it like this. I can pass it under here, but maybe it's not so good idea to pass it exactly in the middle of this component, so I will just do it like this. And here I will come like this. Let's see if down to metal. Oh, that's okay. If I am not happy with the amount of contacts that automatically deselected, I can do it manually, but in this case it is just 15 microamps the output, so it shouldn't be any problem with 9 contacts. I can do it manually more if I want. In the parasitic extraction and later when we used a mirror tool with voltus, we can check if it is enough or not. So I put it there, and in principle I'm basically done with this. I have no more things to connect. Let's run DRC check. This DRC clean. There are things that I can certainly improve, for instance the connection to VDD, but we can check this later if it gives us problem after parasitic extraction. I don't think I need to do something else here. Now let's check if everything was connected. We run an LBS. So we submit this for LBS, and then layout versus schematic. And there is a mismatch. Let's take a look. What can it be? Oh, I have not put the pins. Okay, so still we have something remaining. We forgot to connect the pins here, and then let's do this very quickly. We start with the input positive, and then the input positive should be located somewhere here. So we put it here. Okay, and then something I will really recommend: add a rectangle in metal that you have. So these pins are located are placed in metal 2. Add a rectangle in metal 2 under the pin, under the pin text. Okay, and then to pass LBS we need to do something else. We need to add a label in metal 2, and for that I will prefer to have this in alphabetic order, the layers. So we use layer here. Now it is in alphabetic order. Search metal 2 label, and then here there is a trick. We can do this manually, insert the label manually with L and put it manually, but we can also do auto. And let's see, for that to work we need to not to click in anywhere outside. Nothing has to be selected for this to work. So we put first we select the metal 2 label, we press L, auto, and then we put on the top, and then we see it already gives us some options. So it has already detected that is a net called inp under. We click, and then we select the rectangle that we just added. If there is a path, we can put also the path, but we select the rectangle. It has to be a drawing layer. So apply, and that is correct. And then we need to do this for every single net that we have. So let's take a look very quickly. Press ESC. Next one in N. We move it very quickly here. So I'm going to put it here. We go to metal 2 drawing. I put a rectangle also here under the pin. I select the label, I click somewhere else out so it is not selected the net, and again I'm going to run label auto, and then I could close, and then it has been detected. So I put exactly in the center of the ping. Then I select the rectangle, and then I have botnets there. Let's pick up the next one. We can go with the bias. We pick up the bias, and then the bias is located in the transistor here, but I want to put it here in metal 2. So we put it here in metal 2, and we defined from the beginning these pins to be located in metal 2, but I can change them with Q to any layer that I want, but I will keep this one in metal 2. That is okay. Metal 2 drawing, I make some rectangle in metal 2 drawing under. I click outside, I select the label, and then L from Lima, auto, and then I just get close, and then it is there bias. Click, I select the metal 2 drawing, okay. Now let's go for the last one. VDD I put on the top, so I will put VDD somewhere here. I go to metal 2 drawing, I put a rectangle under, VLAV, auto, and I forgot it has to be click outside, so nothing has to be selected. L, auto, make sure that you are in method 2 VLAV, and then here. Now this label is going to be very small, I can always change it to something else. Let's put it 5, and then it makes bigger. Make sure that it's exactly in the center of the pin, and I select the rectangle that I just put under. Okay, and then that's it. We have 2 pins remained. We have the output. Move the output, and then I'm going to put the output here, and I'm going to put the output in metal 3. That means that I need to change this to metal 3 text. Apply. Okay. And then I'm going to put this one here. I don't need to put a rectangle right now because I put the path here, but it's not strictly necessary. But anyway, for completeness, I'm going to do that. Okay, I put another rectangle here under. And then click outside, label, auto, and then it will be out. And then I put it exactly in the center. Select the rectangle that I added in drawing layer, and it will be the out there. Just save it now, and then I just have the ground remaining. The ground, I decided to put it in metal 1. So I need to change it. The metal 1, I'm going to put it here. Now it is in metal 2. Let's change it to metal 1 text. Metal 1 text, apply. I don't need to add a rectangle, but I might do that anyway. Metal 1 rectangle. Added. The label, I click somewhere else. Label, I put it in automatic, and then it detects that there is a ground under. So I put it exactly in the center, select the rectangle, okay, and that's it. Now think that I can also add manually. I can put a name and then add it exactly on the top, but yeah, if I have the automatic, I prefer to do the automatic. And that should make it. Let's see if now we run the LBS, and then we pass LBS, run LBS, Mate, yes. Okay, now we are done with the layout. There is something else that I will want to do now. I'm going to select everything and move it a little bit close to the origin. And then I will want to either remove or change this outline rectangles that I have. Let's see if I remember how to do that. It is with, here we have to press L, and then we have all the layers, including the ones that are not visible, selected for being visible. And the layer that we are interested is called I think it's border. It should be this one. Device marker. It should be the border. See? No. Where it is? Peer boundary is here, so it is this one here. We're going to make it visible and selectable, and now we have this one here, and I don't know why I see the other either. So we're going to select this one and make it smaller here, and yeah, now it is basically now this is basically done. So this one here, we save it. It is strange, I have another thing here that I don't know what it is. Let's see, make it invisible, this one. There is another layer there, but we will see what it is. Maybe it is the DRC LBS that was putting something else on the top. It's important to not touch that one, so I will make it not selectable and not visible to the peer boundary. And okay, I press L again, and then I come back to the only the visible layers that I need. Okay, so with that we are ready.